Good morning, guys. So today we're going to move on in chapter 9. So we've completed all of the different methods of graphing quadratic equations, and now we're going to get into solving them using some other methods. So one of the easier methods is to solve the equation by finding a square root at the end. While I think this method is probably the easiest one, it is limited. You can only use it when you have a b value of 0. All right, so first let's go over a little bit about square roots. So our objective is to evaluate and approximate square roots and then use them to solve some of these equations. So all positive real numbers have two square roots. They have a positive and a negative. And that's because if you think about it, like what is a square root? So if you have a number like 3 and you square it, you would get 9, right? Because 3 times 3 is 9. However, if you have a number like -3 and you square it, that would also be positive 9 because -3 times -3 is positive 9. So then if we wanted to take like the square root of 9, how do we know which number was squared to get that 9? Was it 3 times 3 or was it -3 times -3? So because of that, every number that we square root, there's two possible roots, a positive and a negative. So the answer to this would be positive or -3. Now, the only exception to that would be 0 because there's no such thing as a positive or negative 0. So when you square root of 0, there's only one square root, just 0. And then if you had a negative number, like let's say you tried to do -9, there would be no real solution because there's no number times itself that equals a negative. Because if you have a negative multiplied by a negative, it's a positive. A positive times a positive is a positive. So a negative number you cannot take the square root of and get a real solution. Square roots are written with the radical symbol, and the number inside is called the radicand. So just to look at a couple examples. So when we're doing the square root of 64, that's basically the absolute value of 8. And that would mean that it could either be, so we're going to say it's an 8, but if you were using this to solve an equation, you'd have to account for both the positive and the negative. But if you're just simplifying in this standard way, when they have just the square root there, they're telling you that's just the positive one we're looking for. If the negative's in the front, then we want the negative answer like that. Square root of 0 is just 0. If you have the plus minus in the front, that means we want both answers, so both positive and negative. And if there's a negative inside, it's just no real square root or undefined. So for example 1, if I asked you what is the negative square root of 121, that means I want the negative answer, so you would say -11. For example B, if I wanted the negative square root of 1.44, that means I want the negative answer. So make sure if you're putting that in on your calculator, you are doing the negative on the outside, or honestly, you don't even have to put the negative in your calculator, just stick it on your answer. Now, if you're doing the square root of, let's say, 0.09, so on my calculator, if I was going to do the square root of 0.09, that is 0.3, and of course, I'm only looking for the positive answer here. For positive or negative square root of 9, we know that we want both answers, so +3 and -3, or if you just want to write it with the plus minus sign in front, that's the same thing. Square root of 7, so if I do that on my calculator, the square root of 7 is 2.645. So I'm just going to round it to 2.65, and we only want the positive answer there. Square root of 36 is 6, and we only need the positive answer here. And then for G, we want the square root of 100, but we want both the positive and the negative answers for that one. Okay. So now let's practice solving some of these. Now this little tidbit here that we're going to do, this is getting into what we're going to do next week with quadratic formula. It's just a little piece of it. So when you're substituting, this is really just practice with your calculator here. So if we're evaluating a radical expression, we need to plug these numbers in. The biggest thing you need to do is make sure you use parentheses. So the b squared is going to be -2 squared minus 4 times A times C. Now, when you put this on a calculator, the regular calculators most of you probably have will need an extra parenthesis here and here. Some of them don't require that. So like the calculator I have does not need those extra parentheses. I'm going to put them anyway just to match what most of you probably have. So if we're taking a look at this one, let me see if I can, I guess I can't minimize this. So we're going to do the square root. Oops. Now, my calculator doesn't need those extra parentheses, but if yours does, it'll usually start with a parenthesis like that. And that's important to know because it's not this -2 parentheses, it's like that extra set in the blue that I put there. So now we need to do parenthesis -2 squared. So second parenthesis, whoops, -2, close it, squared, then minus 4 parentheses A, which is 1, parentheses C, which is -3, and then close that parenthesis. That's telling the calculator that all of that is inside the radical. And then you hit equals, and you get 4. So if you do the whole thing at once, you're going to get 4. Now, what I kind of like to do, and this will help you in the next section, is just do what's inside of it. So if I did it that way, I would say, okay, -2 squared is 4. And then 4 times 1 times -3 is -12. And then when you subtract a -12, it's really addition. So that would be square root of 16. And then that would give me my 4. So you don't have to put in the calculator, but I think sometimes doing it on the calculator is actually more work because you need so many parentheses. All right, so let's take a look at the next one. So I'm going to put in all my numbers here. So my B is going to be -5 squared minus 4 times A, which is -2, and C, which is +2. So rather than put all that in my calculator at once with all the parentheses, I'm going to do what I can in my head. So -5 squared is +25. Be careful. Make sure you remember when you square a negative, it's a positive. A lot of people make a mistake with that. Then we have minus, and then 4 times -2 times +2 is going to be -16. So when I do 25 plus 16, I end up with 41. And the square root of 41 now is the only thing I have to put in my calculator. So the square root of 41, whoops, square root of 41 is 6.4. Now for all of these, we're only looking for the positive answer. We don't have a plus minus or anything in front. All right, and then let's do 2 more of those. So for C, I'm putting in my 6, so 6 squared minus 4 times -3 times -3. So 6 squared is 36, and then I have minus, and then 4 times -3 times -3. Well, 4 times -3 is -12, and then -12 times -3 would be +36, but we're subtracting. The other way you can look at it is if there's 3, I have an odd number of negatives here, this is going to end up being subtraction. But like the last 2 problems, you only had 2 negatives, so then it was going to end up being addition. So that's like another little shortcut you can use. Now 36 minus 36 is 0, and there's only one answer there, 0. And then finally, we'll do the last one. So 5 squared minus 4 times A times C. 5 squared is 25. Notice there's only one subtraction sign here. 4 times 1 times 4 is 16. 25 minus 16 is 9, and the square root of 9 is 3, and we only need the positive answer there. All right, so that's just a little practice of using your order of operations and the radical symbol. Okay, so now we're going to get into how we use this to solve quadratic equations. So we remember from the last week's lessons, we were doing the standard form of quadratic equation, which is ax squared plus bx plus c. Well, the problem with this normally is that we would have to do factoring, which we did in chapter 8, or we'll learn a couple other methods we can use next week. But if you do not have a b value, so like if your b is 0 and that cancels out and you just have ax squared plus c, then you can get the x squared by itself. If you have an x squared and an x, you can't get it by itself because you have two different variables, an x squared and an x. That's when you would have to use other methods like factoring or graphing or ones you haven't learned yet. But if there's just one variable, just an x squared, you're going to just get it by itself like you would for any other variable, and then you just do a square root at the end. So for example, if you take a look at example 3, we have x squared equals 4. So if I'm going to, it's already by itself, so all I have to do is square root it to get rid of the square, because that little exponent, that 2, and the square root cancel each other out. So this is now x equals, and then positive or negative 2. Now, when you're solving an equation, you always have to give both answers. And that makes sense because this is a parabola, actually. So let me show you something. This equation here would actually be x squared minus 4. If I were to put that on my graphing calculator, x squared minus 4, and you graphed it, you see how it crosses through at positive 2 and negative 2. So that's actually what we're solving. So when we did all the graphing in the last few sections and we would find those roots or those x-intercepts, that's what we were finding. It's the same thing, you're just doing it without the graph. So that's why there's going to be two answers. So if you only write down 2 and you forget to write the negative 2, you only have one of the two answers. So you're half right or half wrong. Okay, so let's look at the next one. Again, the x squared is by itself. So all I have to do is square root both sides. So x will equal positive and negative square root of 5. And if you go to your calculator, square root of 5 is a decimal. It's 2.24, we'll round it to. So 2.24. Okay, example C. We have square root again. This time we're just square rooting 0, and there's only one answer. So let's look and see what that looked like on the calculator. So if I were to get everything to one side of my equation, I would have x squared minus 0, so you don't even really need to write that. So watch what happens if I just graph x squared. There's only one x-intercept right at the 0, which is why this one only had the one answer, x equals 0. Now let's try the one we did for example B. This one, if I move my 5 to the other side, right, it's x squared minus 5. So if I do that one, minus 5 graph, you'll see that it's crossing through at negative 2 point whatever and positive 2 point whatever. So you can see that that's what we're finding here. Okay, so now let's see what happens on D. Now on D, you might remember, hopefully from the last page, that when you go to square root of negative, you get no real solution. Well, that means I have no x-intercepts or no roots, right? So what does that look like on the graph? So if I want to get everything on one side of my equation, I bring my 1 over. This would be what my equation looks like. So if I put that in the calculator and I do x squared plus 1 and graph it, you'll see how the parabola is kind of floating above the x-axis, which is why there are no solutions for this one, because there's no x-intercepts. The parabola does not cross the x-axis, and that's why you're getting that answer when we do it this way. So all of these can be checked on a graph. Okay, so now moving on to the next row, and I don't know why, I guess my columns were not big enough, so the zeros kind of got bumped down here by accident, so just... Okay, so what we want to do is we want to get these x squares by themselves. Okay, so if you just remember back to like September when we were solving equations, how do you get that variable by itself? Well, usually we do our addition and subtraction first. So I would add my 98 to both sides here. So now I have 2x squared equals 98. Then I would divide both sides by 2. X squared equals 49. And then I would square root it at the very end to get the x by itself. So you solve for x squared, and then you do your square root at the end to just get the x. So x will equal positive or negative 7. Now, if I wanted to check this on my graphing calculator, this equation, instead of equaling 0, you could have it just equals y, and then I could put it in 2x squared minus 98. So you can see what it looks like. So 2x squared minus 98, whoops, 2x squared minus 98, and graph it. And you can see those two x-intercepts at 1, 2, 3, 4, 5, 6, 7, and negative 1, 2, 3, 4, 5, 6, 7. So the vertex is probably way down here because of that 98, but you can still see the x-intercepts on the graph there. Okay, so for example F here, again, we're going to get the x squared by itself. So I'm going to add 54 to both sides of my equation. So 6x squared equals 54. Divide by 6. 54 divided by 6 is 9. And then when we go to square root that, we get x equals positive and negative 3. Now, if I want to check this on my graph, I'm going to do 6x squared minus 54. So 6x squared minus 54, and graph it. And you'll see it's crossing through at both positive 3 and negative 3. So my roots or my x-intercepts or my zeros or my solutions, all those words basically mean the same thing. Okay, and then we'll do one more here. So I'm going to add the 15. So a 5x squared equals 15. Divide by 5. X squared equals 3, and then I'm going to square root both sides, so I get x equals positive or negative. This is where I'm going to need my calculator because I'm not sure what square root of 3 is off the top of my head. And I get 1.73, so positive and negative 1.73. So now if I were to graph this, 5x squared minus 15, 5x squared minus 15, you can see that it's going to cross through at 1.73 and negative 1.73. Okay, so that's all you have to do to solve an equation for square root. You solve by getting the x squared by itself, and then you would just do the square root and get the two answers. Now, just remember, if you have an x squared and an x in an equation, you cannot use this method. You would have to factor or use quadratic formula, which we'll get to next lesson. Okay, so this can be used, it's used quite frequently in some basic physics problems where you use the falling object model. So if something is dropped or it falls, typically what happens is that object will gain speed as it gets closer to the ground. And that's because of the force of gravity pulling on that object. So this would be ignoring air resistance. So if something is falling, you're being dropped in a vacuum, which means there's no like wind pushing it or things like that. So the H here is the current. All right, it says current height. I always like to call it the ending height. I think that makes a little more sense to me. S is the starting height. Now, sometimes you'll see like an H here and an H sub 0 here. It doesn't matter. It's basically equally. You want to know like what's happening until it hits the end. And so the end is always on the other side of the equal sign, which a lot of times it's 0 because the ground would be height 0. If it's falling and landing on a trampoline or something, that'd be different. Okay, so an engineering student is in an egg dropping contest. The goal is to create a container for an egg that can be dropped from a height of 32 feet without breaking the egg. To the nearest tenth of a second, how long will it take the container to hit the ground, assuming there's no air resistance? So if it's hitting the ground, it's ending at height 0, right? So to write the falling object model, we're going to do 0 equals negative 16 t squared. Now the 16 is representing gravity, so that's always the same if you're on this planet. And then plus 32 because that was the starting height. So whatever you're starting at goes here, and wherever you're ending goes here. So start and end. Usually we're ending at the ground, which is 0. So that's why it says substitute in 32 for S, which we did. So now it said since you want that egg to fall all the way to the ground, your ending height is h equals 0. So that's what we plugged in here. So now we're just going to solve it for time. So again, you want to get this t squared by itself. So we're going to subtract the 32. So we have negative 16 t squared equals negative 32. Divide by negative 16. So t squared equals 2. And then I would square root it. And I get t equals, and when I do square root of 2, square root of 2 is 1.41. And make sure you label your answer with seconds. Now, normally when we square root, we have two answers, a positive and a negative. But why would I only have a positive answer here? Can we have negative time? No. So you're only going to account for the positive answer. If you're dealing with a word problem that the negative wouldn't make sense, then you're just doing the positive answer. Okay, and so that's basically it for today. We will review and go over this lesson again tomorrow, and then we will have a short quiz on Thursday, with Friday this week being a flex day due to Memorial Day weekend. So Friday will just be a day to catch up or make up on things. So when I assign your quiz on Thursday, you can certainly do it on Friday or whatever if you need some more time to review. And then next week after Memorial Day, we'll start with section 9.5. Don't forget to join in one of our reminds if you, not one of our reminds, one of our meetups at 10:30 if you need some extra help or have any questions. All right, and have a great rest of your day.